Frame analysis. Video 13. Concrete design according to first order theory, part 1. In this video, we will show the analysis and design of a concrete structure. It is recommended that previous frame analysis videos have been studied, or that the equivalent knowledge of the program has been obtained previously. We have chosen the switch and X for concrete, and in program part input geometry, built a simple frame structure according to the procedure described previously. Regarding section, we have chosen non-standard concrete, rectangular solid, and from the list selected the two sections 400 by 400 and 400 by 800 millimeters. The former section has been linked to the columns member 1 and 3, and the other to the beam member 2. The material chosen is C4050. In the same way as described earlier, we have in program part input loads created 3 basic load cases. Vertical load, lateral load left and lateral load right, and then combine them as load cases. 2 ultimate limit state load cases and 2 serviceability limit state load cases. In this case, for concrete, it is important if the load SLS load cases are defined as short or long time, in order to take into account the long-term effects as creep if required. The choice on the far right, dependent off, offers the opportunity to create a dependency between load cases. Dependency is quite complex and will not be used in this example, but will instead be described in a special instructional video on this topic. We now go to program part, input geometry, and select input, concrete input, which brings up a box with the name input concrete members. Here is the remaining input for concrete reinforcement and long-term effects specified. We can see a list of the members, and as we want the input given to be applied to all members, we activate first, select the all. The program checks a given reinforcement to see if the capacity of the structure is adequate. If no reinforcement is present, there will be no calculation. If the user knows which amount of reinforcement to specify, this is made under the option reinforcement. But in other cases, it may be appropriate to allow the program to first calculate an initial reinforcement and then increase it if necessary. By activating the choice Calculate Initial Reinforcement, such a reinforcement is calculated. The calculation is made with regard to a first-order analysis and for uncracked sections, so usually this reinforcement needs to be increased, especially for slender structures. We decide to activate this option. We then choose Material Concrete. In this box, under the Material tab, we selected, for example, the environment by exposure class and the lifespan of the structure by the life class. We can also change concrete and reinforcement quality. In this case, we select exposure class XC3 and life class L100. The next tab is called Reinforcement Details. And under Main Bar Details, bar diameter, covers, and other input required to situate the reinforcement are specified. The values required by the code is shown in blue, and these values will be chosen by activating the option Code Values. If the choice Use Regular Spacing in Layer is activated, the reinforcement will be distributed evenly over the section and otherwise concentrated to the corners. We choose the former. If the option Code Control is disabled, the program will no longer check if covers and distances meets the requirements of the code. Under Stirrup Details, can stirrups be deactivated, stirrup diameter selected, the minimum allowed distance between stirrups defined, and the use of minimum shear reinforcement activated.